Welcome dear students. Today we will talk about the properties of some bases. As we know before from previous stage, base has many properties such as number one, when we add litmus paper or litmus solution to base, it changes its color into blue. So base change color of litmus solution into blue. To show these properties, we can do the following activity. As we show, it is sodium hydroxide. Sodium hydroxide is considered from the strongest base, NaOH. Put some NaOH on beaker. Then dissolve base in water. As we show, base also dissolve in water, but its solubility is considered exothermic solubility, which accompanied by evolving heat. Now we will show how base changes the color of litmus solution into blue. Put some of base in test tube. Then put litmus solution on base. To show the color of solution, neutral solution of litmus has a violet color. As we show the color of litmus. Now, as we see before, base changes the color of litmus solution into blue. As we show, the color of litmus solution changes into blue. Completely change into blue. Then we can talk about another property for a base. Number two, base can detect some basic radical. Can detect some basic radical such as copper dye and aluminium trough, where the base such as sodium hydroxide NaOH is a strong base, so this base when adding to another salt solution, for example any solution which contain copper or any solution which contain aluminium, sodium can replace this cation and replace it with a certain color. If we adding sodium hydroxide to any salt which contains copper cation, the solution will change into blue color. While when we add sodium hydroxide to some salt which contains aluminium cation, it changes into white, gelatinous white PBT. To show these properties, now we will talk for each salt as follows. Number one, on adding sodium hydroxide to salt solution of copper, for example copper sulfate, as we say before, sodium is a strong base which can replace another cation. To show these properties, we will know that sodium, we will take the cation of copper NaSO4, and copper take the cation, the anion of base CuOH. But to write the balanced chemical equation correctly, we must write the formula. Sodium is monovalent while sulfate is divalent, so we must write formula Na2SO4. Copper is di, while hydroxyl group is monovalent, so we put bracket by 2. Now we write the formula in the chemical equation in correct way, but we must balance it. To balance the equation, we have only one sodium atom, but here we have two sodium atoms, so we must write 2. Now sodium 2 atom, and oxygen is 2, now 2, hydrogen 2, now hydrogen 2, copper 1, S1O4. So now, as we showed, it is balanced chemical equation. But when we add sodium hydroxide to copper sulfate, we will note formation of blue PBT. Now we will do this experiment to show how the copper sulfate is replaced by Na. Put some salt solution for a copper such as copper sulfate. Then dissolve it in water, copper sulfate salt. Then try to dissolve it in water. As we see, copper sulfate dissolve in water. Okay? When we add sodium hydroxide, as we see in the equation, to copper sulfate, we will see or observe the precipitation of blue color, which is copper dihydroxide. As we show, formation of blue PBT, which precipitate with bathing time. So at the first, we can use sodium hydroxide, which is considered strong alkali, to detect some basic radicals such as copper. On adding sodium hydroxide to salts which contain copper cation, we will observe precipitation of copper. Now we will show secondly how we can use sodium hydroxide NaOH to detect another basic radical plus AlCl3. As we said before, sodium is considered from strongest alkali which can replace easily another cation, Al. And Al will replace sodium to take another anion which is hydroxyl, so the result will be NaCl plus AlOH. But as we say before, to write the right chemical formula, sodium is monobasic or monovalent and chlorine is monovalent, so the right chemical formula is NaCl. Aluminium is trivalent, hydroxyl group is monovalent. By exchanging it will be aluminium trihydroxide. Now we will make the balance of the equation. Only one sodium atom, but number of chlorine atoms 3, but here is 1, so we must write 3. So the number of sodium atoms also increase, so we will write 3. And aluminium, 1 atom, and the hydroxyl group 3, as we see also hydroxyl group is 3. So now it is balanced chemical equation, but as we say before, on adding a strong base or strong alkali to salts which contain aluminium tribasic, we will note that precipitation of gelatinous white BBT. To show it practically, we will do this experiment. Put aluminium trichloride salt in beaker. Then try to dissolve it. Now we try to dissolve aluminium trichloride in water. Now, by adding a strong base NaOH to salt solution which contains aluminium tri, we will note precipitation, or we will observe precipitation of gelatinous white BBT. as we observe, gelatinous matter is formed, which is aluminum trihydroxide. Also, in previous experiment, precipitation of copper dihydroxide, which is blue PBT. So now we will explain another properties in the second series. God willing. Thanks.